options for cursors. All of these, again, you right click in the spectrum window and it opens up these options. Alright, now we will go through the top edge of the software where it has the little words written: File, Edit, Data, Options, Acquisition, Video, Setup, Maintenance, Window, and Help. File is just like any other Microsoft Office program. Open, save, close, delete, print. And in the bottom, it'll save the last couple spectra that you had opened for quick reference, just as if you were using the file option in Word. Next over is Edit. It has cut, copy, paste, a lot of things just like any Microsoft Office thing, and also an undo. If you make a mistake in your data manipulation and you zoom in or you delete something you shouldn't have, you can come up and you can actually click the undo button. The software will remember 5 manipulations of your data. So if you make 6 mistakes in a row, you won't be able to get all the way back. But if you make 3 mistakes in a row, you can come up, hit undo 3 times, and it'll go back. Until you guys get very used to the system, I always recommend that when you first collect your data, just save it. You know, don't touch it, don't manipulate it, don't do anything, just save it. That way you have your raw data, so if you make a horrible mistake, you can just delete what you got and reopen the raw data and start again. Next over is our Data tab. The top edge tells you the name of the current data you have displayed. If we had more than one data open, the data list would display all the data points that we had actively open, but as of now we only have one open. And then data range. In here you can when you open this, it'll tell you the range of your maximum spectrum window that you have. If you wish to manually shrink your window rather than using the magnifying glass, you can just come in here and type in to and from, and it will automatically shrink your viewable window to that range. Or you can just use the magnifying glass, which is easier. In this data range window, you do not want to adjust the size setting, because that tells you how many pixels you are displaying in your graph window. If you change this number to 1, you will have 1 pixel and pretty much no data. Next over, options. Options is where you would change your units from wave numbers or EV or nanometers, whatever you want. So we have nanometers, wave numbers, EV, absolute wave numbers, and THZ. And below that we have count or count per second. If you have low data, we always leave the system set to count, because the count will multiply your data along with your seconds. So if you get 500 counts of data in a 1-second acquisition, if you do a 2-second acquisition, you will end up with 1,000 counts of data. You do a 3-second acquisition, you will end up with 1,500 counts of data. It'll multiply and overlay the data on top of each other. If it's set to count per second, your data will not increase with time. If you have 500 counts in 1 second and then you take a 2-second acquisition, you will technically have 1,000 counts of data, but then the software will automatically divide it by 2 seconds and will only display 500 counts. And then down here we have convert or auto-convert. Auto-convert is going to be if I change units to wave numbers or nanometers, any data that is currently on my screen will auto-convert to that scale unit. If you turn the auto-convert off, then when you change units, the data that's visibly on your screen will not convert. I can show you right here. So we can turn this off. So let's see, options unit. For example, now like we turned off auto convert. And here you can see we're in nanometers. So if I come back up here to options unit and I say wave numbers, my spectrometer has changed to wave numbers, but my data displayed still says nanometers. So then if I come up here, options, change back to nanometers, my spectrometer now is ready. It says nanometers in the spectrometer. If we go back, open options, unit, put back on auto convert. Now if I go options, unit, and change to wave numbers, my spectrum or my spectrometer once again went to wave numbers, and my nanometer data has now changed into Raman shift in wave numbers also. So that's an options unit. That's where you would change scales and auto convert. Next over on the top, acquisition. There's lots of stuff in here. First, it's custom info. This is a little window that can be populated by the user. You can put in any information you want in there about your sample. Specifications, name, date, anything you can fit in the box. And this custom parameter window will be saved with your data. So when you go back later and open the data information window, anything you typed in the custom information window will still be there and visible. Acquisition. Now next is trigger. Trigger is a very annoying option. We will show you how that works right now. So if someone turns the trigger on you, you open the trigger window. There are two options, one to start and one for sample. We turn them both on for now. Say okay, so now if I went to use my little piggy here up top, and the little piggy should take 1 second, one acquisition the way I have it set, and then automatically stop. If I click on it though, it asks me, do I want to start an acquisition? And you say sure. And it says, alright, let me know when you're ready to start it. And you say sure. Then it'll take the data. Where if you have the trigger turned off, and you click on the piggy, oh, I guess I missed one. Hold on. Missed them both. I swore I turned them off. And I click on the piggy. It'll just go and it doesn't ask you if you want to start or not. Next one down under the acquisition tab is going to be the trigger, or sorry, RTD for real-time display. In this window here, this affects your RTD display. If you notice in the top of the window, it says image binging, X and Y. If you ever go to, if you're acquiring a very big map, or you're trying to image on the face of the CCD to see kind of like an old school Raman spectrum, you can actually combine pixels together to form less data points so you can get your data faster. But as you combine pixels together, you have to sacrifice resolution for speed. So for example, if you have a map that's going to run and it's going to take you 15 hours to run this map, if you do binging, X and binging Y, both by say 2, your 15-hour map will now be done in 10 hours. Not sure if that's the right time, just a guess, but it'll be done faster. But you'll have to sacrifice a little bit of image resolution because now you're not using all the pixels. And you can bing all the way up to 32 times, which is really horrible resolution, but you will get map data really, really, really fast.